Number 9. So, let us have a look over some randomly generated questions. Alright? These are just some exploratory sort of data analysis, if you see what I mean. So, first of all, let's have a look. So this is number 9. This is number 9 Q&A. Okay. Make space. Okay, so let's have the first question to be do males or females have more ITNs? Just in pure sort of numerics. The way we do that, we want to have a look at our data frame. We want to filter, because we want to see who's got the ITNs, we need to filter them to make it 1. Sorry, filter ITN equals 1. So now we've got the population subset that has all the 1s. So imagine if you've got a filter section in your, like an Excel document or something like that. Okay. Then after this, we want to just do a simple count sex by ITN. Simple as that. Right. So it shows that in the little box down there, females actually have more. Right? But it's quite literally that simple. And we can have a look who has more data like what the population numbers of the males and females are. So then in that case we just do count and then we just do sex. Do that, then you show that actually there are more males. So it kind of shows between these two that females seem to go and have an edge in mosquito net distribution, as there are females seem to be getting more mosquito nets and there are more males. Yeah. However, that's you can take from that what you will, that there is mothers with should be protected more from malaria, because you're going to be affecting 2 people at the same time, so it's not accounting for pregnancies in this case. So so you can't just go and scream it's unfair or whatever, or anything like that, because there are other issues that haven't been looked at. So number 2, let's say which sex has the highest proportion of ITN. So this is essentially taking this argument. I just did this quickly by having a brief gander, but you can actually have a look at it via proportions. So saying one's higher than the other. So in this case, we'd have a data frame. So I'll write it down. Which sex has the highest proportion of ITN? Okay, so let's have a look at our data frame. Let's pipe it. First of all, let's filter sex equals, because it's a string, male. Let's have a look at them individually. Okay, we want to count ITN, and then we want to count sex. I'll pipe it again. Then we want to go and make a proportion, so we want to mutate. Then we want proportion equals, you should know this by now, n divided by the sum of n. And yeah, there we have it. Then after that, we can just do exactly the same thing to go and get of, we'll put FE for female. And we plug them both in. Whoops, that is the problem with copying and pasting, because I might be copying and pasting something completely incorrect. Perfect, okay. Skadoosh. Okay. So now we can go and see that the proportion of those with and without nets, we can see that actually the females at the bottom with nets, with ITN equals 1, it's 56%. And the other one is 51%. So it shows that proportionality, females actually have more access to nets. Okay? Now let's have, and that's essentially just a long-winded way of, well, you can just look at the numbers individually up here with the thing above. I mean, it's a lot less writing, I guess. Yeah. So anyway, let's have a look at number 3. So let's say, what can I say? Okay. What age group has the highest proportion of ITN? Which age group has the highest proportion? So now you can go and you can squish them together. However, when you do your counts, it's just going to be a big list, if you see what I mean. Which is, I find it sometimes easier in my head just to make things separately and stick them together. So let's have number 1. Yeah, number 1. And have our data frame. We're going to make a new thing, okay? We want to filter for sex equals male. Just going to get the male sections. Sorry, highest proportion of ITN, sorry, not sex, it's going to be ITN. ITN equals 1. That's right. So we want to have 2 sections. So we want to have the ones with the ones and then the zeros. Okay, so we'll make 2 of these. 2 of these, so they're split. They both add up to 500 observations. So now let's have a look at no 1 1, and that's taking data from that. We want to count ITN with age group factors. And then we want to do the same for 0. So that'll be 0, 0. I know this is a convoluted way of doing it, but it just seems simpler in my mind, if you see what I mean. Because you just go and get a list of things that you can't proportionalize. Okay. Now, there's going to be an issue here because they're going to be called the same thing. Now, in this, it is best to rename. So, when we fix them together, they're going to have exactly the same names in both. are they exactly the same? No. 0. So they're going to have exactly the same names. So what we're going to want to do, we want to rename N0 is going to be N to count the ones that don't have nets. ITN 0 is going to be the ones we're going to be using instead of ITN. And age group factor zero is going to be age dot group factor. So that's we're just going to rename them. All right. Okay. Now let's have. So now we've got our these two. They're renamed. You can see and 0, etc. Now we're going to want to squish them together because they're exactly the same. They have the same number of age groups, right? You see ITN 0, etc. So, what we're going to be doing, we are going to make a final one, and then it's going to be a column bind, cbind, no, and we're going to bind both of these together. Okay. And it's going to be called fin. Skadoosh. So now, it wouldn't work because if the names were exactly the same. So you got the 0 group, the ones without, and the ones with ITNs. Now we can make a proportion because we can go and have a look at this versus this. Instead of if you did it just by ITN, and via a group by function, then this would be under there and it would go to 16. And then you can't just sort of go jum to dum jum to dum, although at least I can't at the moment anyway. So this is just an easy way for me to go and get everything along a line, if you see what I mean. So here is what we do next. And it's quite simple. We want to do our fin. We want to do a mutate. Then we want a proportion equals the number with divided by N0 plus N. This needs to be in a double brackets. This needs to be. So what we're doing, we're saying that plus that divided by this to go and get a proportion who in each age group who actually has a net out of their total population in each age group, if you see what I mean. Yeah. And in that we can have a look. And now we can see within this simple calculation that out of the proportions, the highest proportion with is actually the most elderly. They have the highest proportion. Now let's say after this, then we want to do pipe, and then we want to do a GG plot, we want to do aesthetics, then we want to do x equals age dot group factor 0 at the bottom, and then we want y equals proportion sorry, geom_col, and we want to match that. You can see that the highest proportional group who actually have it is actually the oldies. Is it still going? Yeah, it's still going. Oh, 15 minutes. Jesus. Okay. So that's just it's just an interesting thing to go and have a work through, and I've shown you a couple of examples of how to start moving data around, chopping and slicing it. So let's have a look. Okay, this should scratch your noggin. Oh, actually I should be numbering these. 3. This is number 4. Okay, this should be a bit difficult. When I was doing this, I was pulling my hair out. Which house? J-U-S-E. Which house has the highest number of occupants? So in the data frame itself, you have person IDs. Each of these IDs here is unique. However, HHID stands for the house. So you can see multiple people are living in one house. So what do? Do you count data frame, count the number of HHID by the what was the occupancy one? Person ID. The person ID. Do you do that? Absolutely not. It just goes and gives you a whole list of this by this, which is essentially, because one of them is unique and one of them is not, it doesn't particularly matter. It's gonna show just these two together with ones next to them. That's it. That's all it's gonna do. So what do you do? Well, I'll tell you what you do. You get rid of that. Because each of the columns is a unique identity for the person, this person ID should actually be over here, because it's the key. It's the key. So if you just have a look at the HHID, count HHID, then you're going to go and get the number of iterations each of the house IDs actually comes up. Now, if you want to go and get the highest one, then you can go and do an arrange for descending order, and you want to have a look at the number, which is n. You want to go and get the highest one, and that shows house number 108, or the ID 108, actually has 16 occupants living within it. Yes. So you need to make sure you're very careful in knowing what your data is showing, and maybe rearranging it. Yeah. So okay. Then. So let's go to number 5. Which house has the highest number of women? Data frame. What we want to do, we only want the women out of the data, so filter sex equals female. Female. Ooh, before that, let's have a look at view data frame summary, and I want to do a data frame. Let's just have a look at this. So let's have a look at there are no. It shows that there are no missing ones in this. because as you can observe. Okay, that's cool. That's fantastic. Yeah, let's just get rid of that. So just making sure that there are no NAs or anything like that. So what do we do after that? Well, what's the highest? Which house has the highest number of women? Well, we do exactly the same. Count HHID. Then we want to do another pipe, and then we want to do arrange in descending order the number that you get at the end. Skadoosh. So we can see that actually 122 has the highest number of women. That's before actually. Oh no, it was 108. Okay, let's no, we can do. What is that doing this? And that just shows you, making sure that you can see it. Maybe number 6. Which house has the highest number of men? Same thing. Take away that. 108. Wicked. Okay, that's number 6. Okay, which house has the highest number of ITN? Okay. Which house has the highest number of ITN? Okay, so we want to do data frame. We want to have, okay, so ITNs, highest number of ITNs, we don't want to include the 0. So, we want to filter ITN equals 1. We want to pipe it. Then what do we want to do? Have a think for yourself for a sec. That's pretty simple. Count HHID. We're only interested in ITN. Another pipe. Arrange. Descending order. Number. Boom. And show that highest number of ITNs. 122. Let's have a look. 122. 122. 122. Okay, so we've got all of these. So we've got, which ones have ITNs? Oh, that's LLIN. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Number 13? It absolutely is. Okay. Now, let's say, to be fair, we don't really care about which ones have the highest. We want the lowest. Do exactly the same thing. You want, because they're the ones that need attention. 108. That house is not doing so well. Now, I'm going to leave the next question because this is getting a long time and I don't know how it's going to process it, but the last question is a difficult